Hi there, here is a project for the week, Hydroponics IoT Monitoring and Control Project. Here is our circuit diagram, and this is how we're going to be constructing this particular circuit diagram. In the circuit diagram, we use a pH sensor, a TDS sensor, a humidity, digital humidity and temperature sensor. We used a soil moisture level to do our water gauge, and now we're going to be constructing a standalone microcontroller unit, which is also the MCU. For the MCU, we need the Arduino 28PU sockets, and that's actually how we're soldering it now onto the steel board. After soldering each side, we demarcated it using a sharp blade, and after that, we're going to be putting our 16 megahertz crystals and our 22 picofarad to the respective pins according to the circuit diagram, and from there we are going to be soldering our indicator. And after soldering our indicator, since we're going to be using an FTDI programmer, we are going to be soldering 6 female header pins to do that also. Alright, so over here we could see that we're soldering the FTDI ISP programmer male header pins, so we can easily connect the female to it. And after that, we're going to be soldering our 16 by 4 LCD socket, on which we're going to be plugging our LCD wire to it. And we're very careful that we're going to be using a 10K potentiometer to adjust the contrast of the LCD, so we solder that onto the strip board also. We mind not to do any short connections to the soldering, because it was very important. If not, our whole design is going to be damaged. Basically, what the whole design is all about is to design a hydroponic monitoring system that can be able to monitor the status of a hydroponic farm using special sensors like pH sensors, TDS sensors, humidity and temperature sensors. And these particular sensors can send their values or their readings to a particular cloud database, like Teamspeak, and from there the users can always view the status of the farm from anywhere around the globe. Also, the project is also designed to use a mobile app, which we are still going to be building in at the later end of this particular tutorial, such that it can read directly from the Teamspeak database, and any user can automatically open his Android app and then view the status of the farm. Also, the project also designs the MCU board to also display the readings of these sensors on a smart LCD screen. This makes it actually 3 ways where we can view the status of the hydroponics farm. Alright, so here we're testing our MCU board. After that, we're going to be connecting our various sensor to it. The first thing we're going to be connecting is the LCD module. So from here, we're using the 16 by 2 LCD is working perfectly. Over here is the TDS sensor, and how we're supposed to connect it. This is the source code for the TDS sensor, which you can find below the link on this particular video. We upload it and we can test to see the reading of the TDS sensor. But from this particular reading that is going to be showing here, we could notice that the TDS sensor is not reading very well. And this actually is because of the TDS probe has a leak, so the water is actually is getting in between the probes. So we could just try this right away and solve that particular problem. The next thing that we are going to be connecting is the temperature sensor, which will be using the DS18B20 waterproof sensor, since we are going to be measuring the temperature of the nutrition water, which from which the hydroponics plants take up their nutrients. Okay. That being said, okay, here is the TDS probe and the readings is shown. Okay, and here is the connection for the temperature sensor. From here, we could see that a 4.7k resistor is connected between the VCC and the output of that particular sensor. And here is the reading of that temperature sensor. After that, we're going to be connecting the DTH 11 digital humidity and temperature sensor, and we're going to be uploading the source code for it. And here is our water levels gauge. Here we use the soil moisture sensor for that, which was very low cost and very efficient. Okay, so here is the source code for the DHT11 sensor, and it can also be found below this particular link here for of the video. After this, we're going to be connecting our single channel relay module. We're going to be casing the whole project together. For this particular project, we're going to be using 12 volt switch mode power supply, and we're going to be using that because we're going to be using a solenoid pump which uses 12 volts for its activation, and we're going to be using we're going to be converting 3.3 volts from this particular 12 volt using a buck converter, which we're going to be using to power the ESP8266 the Wi-Fi module, and we're going to also be converting a 5 volt from that same 12 volts using a buck converter, which we're going to use to power the microcontroller unit. So here we're switching the buck converters to the power supply. Two buck converters, one is giving us an output of 3.3 volts and the other one is giving us an output of 5 volts. And after all this is being done, we can case the whole project very well to ensure that everything is in order. All right, the whole project is being programmed to work in an automation mode, such that if there is an elevated temperature in the nutrition water, where the hydroponic plants are supposed to be absorbing their nutrients from, automatically an alarm goes off, and then the solenoid pump automatically turns on to decrease that particular water temperature. Also, when the water level gauge reaches below a particular level, the solenoid pump is also supposed to be turned on automatically so as to increase the nutrition water in the base tank. That being said, we do all our connections right, and from here we can just upload our source code and go to Teamspeak to view our data on the cloud. The ESP826601 Wi-Fi module is very important to the development of this particular project because it gives us the access to our Teamspeak cloud platform. The connection of the ESP into the project is shown in the circuit diagram, but it will also be wise to note that the ESP826601 needs at 3.3 volts, but it can take up to 1 amps of current. So here we're connecting the single channel relay model, which is going to be switching on the solenoid pump so that the water can be turned on into the base tank. All right. Off. So now we're going to go over to Teamspeak. We'll log into Teamspeak website, and by getting there, we'll see their homepage and we'll sign up. Or if you haven't signed up, but we already had to done that, so we'll just sign in into our account. So by signing in, we can then go ahead and create a new channel. We can name it whatever we want, but what is really important is trying to know the channel ID, and also knowing the API right key and also the API right read key, because with the API right key we could program our microcontroller to send our sensor data to our Teamspeak database, and with the API read key we could program our Android app to read from the Teamspeak database. Right, so next on the list is heading over to MIT App Inventor to program our app. So looking at here, we can see the block form of the app. Everything that we define here, the global variables and um, other particular blocks that we use in developing this particular app. So we in the MIT App Inventor, you have the designer's part, and you also have the block part. And the designer part, you design how your app is going to look, the outlook of it all. But here in the block part, you actually program how the app is actually going to respond to every particular command whatever you want it to do. So you could just see from here that we'll define our global variables, and from there we'll use the Teamspeak read API key, so we can automatically read the sensors data from Teamspeak database, and it was going to be displaying on our app. That being said, I will leave you to study the whole block part yourself, or you could just simply download the .ai .aia file beneath this particular video, and upload it to your own Teamspeak. This is actually the total the finishing app look of it.